Dear students, in physics you have seen the apparatus, you have seen many physical apparatus you have seen in the lab, but those applications, apparatus applications, you never come across how it is being applied in mathematics, how it is being used by mathematics, that you do not know. Let me briefly explain about how physical components of physics lab apparatus being applied into mathematics. Now let us see. The spring balance, you might have seen the spring balance in physics lab. The physics lab, the spring balance is given to you. You might have seen, how we can take the measurement of the length, how we can take the weight of the substance which is hung on the spring balance. Those things you have seen. But now the same problem, how we are going to utilize, how we are going to apply it in mathematics. That is what we are going to look into this problem. Even in physics, you can use the same type of formulas, same type of applications with the help of mathematics. That is very well you can use it. So let us read out this problem. In analytical geometry 2 dimension, in exercise 6.2, sum number 13, page number 260, this problem is given to you. The sum is very big sum it is, but answer side and by way of seeing this one, it is a lengthy one. But on the whole, when you are seeing the problem, it is something different, something confusion maybe for you, but things are very clear, crystal clear concept. That means all the values are given to you very narrowed way. So narrow way is given. It's not looking into something back and we have to define with some more concept, nothing else. All the values are directly given to you. You have to identify what is to be calculated for each problem. There are 5 problems are given, 5 subdivisions are given for this particular problem, but very simplified way we can calculate each part. Let me read out the problem. A spring was hung from the hook in the ceiling. That is the first line is given. Hook. So the spring. So there is a thing in the hook. The spring. Like this, something is given to you. The spring is given. It is hung in the, what is that, ceiling. This is a ceiling and it is fixed, the spring, and some weight. Suppose the weights are given here. Weight we put it here. This is spring and the weight is given and we wish to know what is the equation of this. That is the question. The first line, a spring was hung from a hook in the ceiling. This is a ceiling, this is a weight, this is spring, this is a length. Depending on the weight, that the length also will vary. That is the thing is given here. So the weight in kgs and length in centimeter. The spring length will be in centimeter and weight in kgs, that is given. So I wish to take the first one is nothing but x here. Here a number of different weights were attached to the spring to make it stretch. So it should be stretched. That is attached to make it stretch, and the total length of the spring was measured each time as shown in the following table. This is a table given you as the weight of 2 was put. So the length of the string is 3 centimeter. When I add up 2 more, that is 4 kgs, so the length will be obviously proportionally increased, that is 4. When I increase the weight 1 more kg, that is 4 plus 1, 5 kgs. Obviously the length will be increased 4.5. When I put some more length, some more weight 8 kg, the height of the length of the string is increased by this much, that is 6 centimeter. So likewise when you put up weight over here, the spring will be totally increased proportionally. That is what given. First you understand the question. What is given? Weight. Weight is nothing but, that is weight in kgs given, that is x. So let me take out that very simplified way, and length in kgs in centimeter, that is y. First 2, 4, then 5, then 8. 2 means it is 3, 4 means 4, it is 4.5, and this will be 6. Let me draw the first question. Draw a graph showing the results. Draw graph showing the results. Let us take weight in x kgs. Let x axis be the weight, and y axis be length of the string. This is in terms of kgs, this is in terms of centimeter. So let me just draw this diagram one as a diagram here. So each part 2, 4, 5, 8. So I can take, this is a weight in kgs. So 2, 4, 6, 8, 10 like this, and here I can take 1, 2, 3, 4, 5, then 6, like this I take here. Now 2 and 3 means this point, 4 and 4 here, and 5 and 4.5 over here, and 6 and 8 and 6, I'm sorry, here 2 and 3 here, 4 and 4 is this point, yes, and 5 and 4.5, okay, like this, and 8 and 6. 8 and 6. You join all these points, that is 6 here. 8 and 6. Join this, so we are getting a straight line for this. We are getting a straight line for this. So here this is a point which is nothing but, here it is nothing but 8, 6, 4, 5, 4.5, 4, 4, this point is 2, 3. So first one is over. The graph of this is weight and this is length of the string. Length of the string. Length of the string is y axis, this is x axis. Weight of the string is x axis. Length, as in when you put load on the weight, so obviously the height, the length will be increased. It is a linear equation. We got a linear equation. By seeing linear, immediately your mind has to recall what is to be formulated for this problem. What is to be formulated? Nothing else. You are very clear, we got a linear equation for this. It is a linear equation, so linear curve. Linear curve means you know that it is a straight line formula. you need to recall the straight line formula, for which at least we need 2 points to find the equation of the given line. For this at least we need 2 points to just to find out. So here if I want the second one, find the equation relating to the length of the spring to the weight on it. So we have to frame the equation for this string, for this one. And what is the actual length of the string? Actual length means what? Without putting anything on the string, original spring is there. When you are not loading anything on the spring, the initial position is 0. By then what would be the length? We want to know. When I am not putting anything on the spring, when I am not putting anything on the weight balance, so definitely the spring never stretches it as it is, so that means we won't get any kind of measurement. So that means the initial value of x is 0, we want to know what is the value of y. And if the spring has to stretch 9 centimeter long, that means y value is given here. That means here the value of x, the spring has to stretch. So what is the actual length of the spring? That is the thing. And what is the stretch 9 centimeter long? How much weight should be added? How much weight should be added means they ask you to find x, they are given the value of y. Y is 9 centimeter. We ask you to find what is the value of length. The spring has to stretch 9 centimeter long, so we need to find what would be x. How long the spring be when 6 kgs of weight on it? That is a fifth and final question. Suppose x is given as 6, and what would be y? The first question I finished here. What is the graph of this? We finished that. It is a linear curve. And for the second one, we have to apply that formula. So we have to apply the second one. For need, at least we need 2 points. You take 2 and 3, 4 and 4. So you take 4 and 2 and 3, 4 and 4. So we can get the value here. So I will take, let 2, 3 is one of the point, 4, 4 is another point, be the points on the line. So this is x1, y1, this is x2, y2. So I can apply that formula, y minus y1 is equal to by y2 minus y1, x minus x1 by x2 minus x1. I can apply that formula over here. So what formula it is? Nothing but y minus y1. Y minus, what is y1 here? So I can take it as 3 here. That is 4. This is x minus x1. x1 is 2. That is 3 here. 4, I am sorry. This is 4. So like this if I take, so what I am getting this part, y minus 3 by 1, x minus 2 by 2. So y is equal to 3 plus x by 2 minus 1. So x by 2 plus 2, that is y. So we identify what is the result. Y is equal to x by 2 plus 2. This is the first result which I got for this line. So now I found out the second one, and the second one we have completed. So we need to calculate the equation relating to the string. That is what this is the relation for y is equal to x by 2 plus 2. That is the second one. And in other words, if I want to simplify, I can simplify it. So 2y x plus 4. So the 2 and 2 LCM we have to take, x minus 2y plus 4 is equal to 0. Likewise, so here let me see here. So x by 2 minus 2 by 2 and minus 3, if I take the other side is plus 3, that's okay, fine. We found out the result is like this. So here x minus 2y plus 4 plus 2 into 2, 2y. So, x minus 2y plus 4 is equal to 0. This is also an equation. Whatever it is, that is not a big thing. Okay. Now, what is the third question? What is the actual spring? What is the actual length? Third one, actual length of the spring. Initially, the spring was, there is no weight, so that 0. That means we have to put here, x is 0 here. What would be the length here? So, when I put x 0, so y is equal to 0 by 2 plus 2, which is 2. So, y is equal to 2 centimeter. So, the spring length is actually, initially, it was 2 centimeter. We are not putting anything on the weight on the spring. The original position of the spring is, the length is 2 centimeter, because the initial weight is 0 here. What is the fourth question given? If the spring has to stretch 9 centimeter long. So, the fourth one, so we wish to stretch, instead of 2, we have to stretch some more, what is that, length. So, we need to get this 9. So, when y is 9, what is x? That is what they ask you to find. How much weight if I put, the spring would be elongated or expanded, that is 9 centimeter. So, that means I wanted to know from this, just substitute here. This is a main equation actually. This main equation is this. So, 9 is equal to x by 2 plus 2. So, that means 7 is equal to x by 2, which implies x is equal to 14 kg. So, if I put 14 kg on the weights in the suspension here, the spring will be elongated 9 centimeter. That is the way that the fourth one would be like this. So, that is when I put 9 centimeter, 14 kg if I have to apply. How long the spring be when 6 kgs of weight put on? If I put 6 kg, so if I put 6 kg here, the fifth question, when x is equal to 6 kg, what is y? So, it is in terms of centimeter we have to calculate. This is 9 centimeter and x we found it as 14 kg. If I put x is equal to 6 kg, how much y? So, I have to once again substitute over here. So, y is equal to 6 by 2 plus 2, which is 3 plus 2. That means y is equal to 5 centimeter elongation. Now, let me recall all the steps of this one. So, here for the fourth question this, and for the fifth one is this much. The first part, according to the value given, we drew the diagram of the linear curve with the help of 4 points. With the help of 4 points, we drew the diagram, that is a linear curve. By seeing the linear curve, we are recalling the 2-point formula. By way of taking any 2 points, we have 4 set of points, but we can take any 2 points, we can arrive this equation of a general equation of a spring, that is y is equal to x by 2 plus 2. That is the one we have here. Y is equal to x by 2 plus 2. This is the spring length, that is the equation here. Actual length means we have to take initial one is 0. Obviously, you will get the value of y, that is 2 centimeter. Initially, there is no weight is put on this spring, that the spring one. So, that means the weight, the length of the spring is 2 centimeter. If I need to get 9 centimeter length of the spring, how much weight we have to put on that. So for that I just substituted over the general equation which I arrived. So substituted, I found out 14 kg. If I put 14 kg over here, I must get the spring elongated 9 centimeter. Now when I put 6 kg of weight, already it is given 2, 4, 5, 8. Obviously it is between 4.5 to 6. Now I got 5 centimeter. It is also correct. By seeing that, see 5 to 8 means 6 middle. So that is 5 centimeter. So in all the 5 cases we have discussed, all the 5 cases you are clearly understood. Simple formula, only 2-point formula only for this spring.